Dear students, welcome to s.mathguru classes. So our main discussion is linear differential equation, linear partial differential equation with constant coefficient, and we solve some problems if right hand side is exponential given. Our last video it was given, and we consider if right hand side trigonometry given, what will be the particular integral and how to solve the problems. Now let us consider one problem. Solve the linear partial differential equation. Del square z del x square plus 2 del square z del x del y del square z del y square equal to sine twice x plus 3y. Now we want to solve this problem. So this can be written as capital D plus 2D D dash plus D dash whole square into z equal to sine of twice x plus 3y. So this is x square with a d square, x, y, then d dash, and this is y square, d dash square. Now we find auxiliary equation. Auxiliary equation equal to m square plus 2m into 1 plus 1 square equal to 0. Just putting d equal to m and d dash equal to 1. When you have to find auxiliary equation, then you putting d equal to m and d dash equal to 1. This implies m square plus twice m plus 1 equal to 0. And this is m plus 1 whole square equal to 0. From this we get m equal to minus 1 minus 1. So what we get, the roots are equal. Therefore, complementary function is that f1 y minus 1x plus x f2 y minus 1x, or we can write f1 y minus x plus x f2 y minus x. This is our complementary function. Now we find particular integral. Particular integral equal to right hand side sine of twice x plus 3y divided by d square plus 2d d dash plus d dash square. This one, d square 2 d dash square, d dash square. Now we putting the values in this way. So sine twice x plus 3x, this is remains same. Twice x plus 3y remains same. In place of d we putting coefficient of x with minus sign, and in place of d dash we putting 3. So d we putting 2 plus 2, this is minus d dash, d means 2 and d dash means 3, plus minus plus d dash square, d dash means 3, so this is minus 3 square. So we get this one minus 3. Just we write d square equal to minus 2 square, d dash equal to minus 2 into 3, and d dash square equal to minus 3 square. We write in this way, we get this one. So this will be sine of twice x plus 3y by minus 4. This is minus 6, this is 12 minus 9. So this will be minus this is 1625 sine of twice x plus 3y. This is our particular integral. Therefore, the required solution is Z equal to CF plus PI. CF plus PI. CF means this is F1 y minus x plus x, F2 y minus x plus pi. Pi means minus 1 by 25 sine of twice x plus 3y. And this is our final answer. Just required solution or general solution, complementary function plus particular integral. Complementary function we know this, and particular integral just we get this one, and this is the final answer. These are very easy and very interesting also. Now we consider another problem. Solve the linear partial differential equation del square z del x square minus del square z del x del y equal to sin x cos twice y. Now solution. So this is we write d square and this one d dash and z equal to sin x cos 2y. Auxiliary equation m square minus m into 1 equal to 0. So we putting d equal to m and d dash equal to 1 for finding auxiliary equation. So this implies m common, m minus 1 equal to 0, and this is m equal to 0 and m equal to 1. Therefore, complementary function equal to f1 y plus 0x y plus 0x plus f2 y plus 1x, or we can write f1 y plus f2 y plus x. We write in this way. Now particular integral. Particular integral equal to sin x cos twice y by d square d dash. This one particular integral. Now actually our particular, when you have to find particular integral, the trigonometry only sin and cos must be in the form of sin ax plus by or cos ax plus by or ax minus by. We can write this. But here we get this one. So this is d square minus d dash remains same. We multiplying here 1 by 2 and here sin 2 sin x cos 2y. We write this. So 2 sin x cos 2y. But you know this formula, we know this formula 2 sin a cos b, this equal to sin of a plus b plus sin a minus b. 2 sin a cos b equal to sin a plus b plus sin a minus b. 2 sin a cos b, we assume x means a and y 2y means b. 2 sin a cos b. So this will be, this is d square d dash remains same, and here 1 by 2 we get sin x plus 2y plus sin x minus 2y. Just we using this formula a plus b, a minus b, so we get this. Now we separate this, half is common, we separate this sin x plus 2y d square minus d dash plus sin x minus 2y d square minus d dash. We get this. 1 by 2 remains same, sin x plus 2y. This is d means we putting coefficient of x is 1, 1 square. This is minus 1 square, because this trigonometric given minus 1 square, and this is minus d dash d dash. D means 1 and d dash means 2. Coefficient of y in place of d dash we putting. And here sin x minus twice y minus 1 square. D means, first we write minus, d means 1 square, and sorry 1, d means 1 and d dash means minus 2. We get this one. 1 by 2 sine of x plus twice y minus 1 plus 2 sine of x minus twice y. This is minus 1 minus 2. We get this. 2 minus 1, 1, then 1 by 2 sine x plus 2y minus 3, then 1 by 2, this is minus 1 by 6 sine x minus 2y. So we get this is the particular integral. Therefore, the required solution is z equal to cf plus pi. This implies z equal to cf. Cf means this one, f1 y plus f2 y plus x, and this is pi means 1 by 2 sine x plus 2y 1 by 6 sine x minus 2y. This is our answer. So f1 y plus f2 y plus x plus 1 by 2 sine x plus twice minus 1 by 6 sine x minus twice. This is the final answer, and this is our complete solution of the given problem. Now we consider another problem. Solve the linear partial differential equation del square z del x square del square z del x del y equal to cos of x plus 2y. Solution. So first we write this d square minus d dash equal to cos of x plus 2y into z, this one. Now auxiliary equation m square m into 1 equal to 0. That means putting d equal to m and d dash equal to 1. This implies m common, m minus 1 equal to 0, then m equal to 0 and m equal to 1 we get. We get two values of m. Therefore, complementary function equal to f1 y plus 0x f2 y plus 1x. This equal to f1 y plus f2 y plus x. We get this one. Now particular integral. Particular integral means right hand side cos of x plus 2y divided by d square minus d dash, this, and putting this is cos of x plus 2y, and in place of d we putting coefficient of x with minus sign, minus 1 square, and d means this is minus 1 minus 1 into d dash means 2. We get this one, and this will be cos of x plus 2y by cos of x plus 2y by minus 1 plus 2, minus minus plus 2. That means 2 minus 1, 1. We get cos of x plus 2y. Therefore, Therefore, the required solution is Z equal to CF plus PI, complementary function plus particular integral, and this equal to Z equal to CF. CF means F1 y, F1 y plus F2 y plus x, and Pi means x cos of x plus 2y. So this is the final answer of the given problem. So we have a big answer. This big answer represent today we want to stop here. So I want to stop here. So dear students, these are very easy problem, very interesting, very simple. And if you are getting interest, then please share this video to other friends also, engineering friends and BSc major also. These are most important. It may be in second semester, third semester, but these are important for engineering courses and mathematics major also. So, if you are getting interest, then please like this video. If you are new in my channel, please subscribe my channel and click the bell icon. Thank you.